Okay, so today we're going to work on your guys' homework from day 5, Dilation and Angles, which is homework number 4. Right. First thing first, I'm not going to help you with the first section. I'm going to tell you right away, all of this can be found on your notes. So, not even going to fill those in. Go back to your notes, take a look at those, and then get them for yourself, please, and thank you. Okay. So, what I want to take a look at is problem number 4. Okay, if a rectangle, well, there's not a picture, let me draw one. That should be your first step. R, S, T, U. Okay, is dilated with a scale factor of 1/2 in the center at R. What does that mean? R is not going to move. STU will move. So I'm going to draw it right within the image of how it would really look. It's going to get shrunk by half, so I'm going to go about halfway for each one of these, creating S prime, T prime, and U prime. Okay. Which of the following is the value of measure of angle S prime, T prime, U prime? Let's take a look. S prime, T prime to U prime. They're asking for this angle. I'm going to leave it as that. If you can't figure that out, please ask me in class. Okay, number 5. In the following diagram, D to E lies on sides AB, there's D on AB, there's E on AC, such that DE, and I missed that sign, it's parallel, but if you look in the diagram, you can see the triangles for parallel as marked. Okay, it says we know that A to D, there's AD, that's 18, and DB is 12. Okay, so be careful what they gave you. They gave you AD and they gave you DB. Those are the two pieces they give you. Give a dilation that would map BC onto DE. State both the center of the dilation and the scaling factor. Okay, so if you look in this diagram, we should be able to see the center. Obviously A. A is the center of dilation. Just to help you out on that. Now we have to figure the scaling factor. Now remember, when we're doing the scaling factor, we talked about the two triangles. So I'm going to finish the small one in pink, but I'm going to redo the big one in yellow. Okay, now remember, when we figure out the scaling factor, it's the original times the scale factor that would give you the dilation. Okay, so the question is, which one of these is the scale factor? Now, if DE are lying on side AB and AC, that means ABC is your original. Okay. What they gave us, though, from this whole entire yellow triangle was only this small part of 12. So do remember that we need the whole entire length, which means we should probably add these two numbers together. That will give us 30. So we're going to do the original of 30 times a scale factor of K to bring us down. Remember, the small triangle is 18. Okay, from there you should be able to solve it. Okay. In B, this is where we would need to set up some proportions. Okay, so if BC is 15, then we know that this is 15 now, and we know that A to C, this whole thing, is 20. We need to find the perimeter. There's a keyword. Means add up all sides. Okay, which means that I don't have DE and I don't have AE. Okay, you can set them up by doing a simple proportion. Big over small equals big over small. Okay, so let's set this one up. Big AB is 30 over the small triangle, that's 18, is going to equal big BC of 15 over small of DE. We need to find DE. Okay, look back at your notes if you need to at this point. Find out how much DE is. Okay. You also need to find AE. So I'm going to set up the same thing. 30 over 18 is going to equal, now if we need to find AC, its matching number is, AE, its matching number is AC. And that's a big number, that's 20. So 20 over AE. Cross multiply, divide. Okay, now remember, you're trying to figure out perimeter of triangle ADE. So that means you need to take side AD, add to it side DE, add to that side AE to get your answer. Okay, now in number 6, that's your extra credit. Okay. Now it says it's an isosceles triangle. So the best thing is to help yourself with these is to draw a good picture. Whenever they don't give you a picture and they're talking about shapes, it's always good to draw one. Okay, AB is equal to AC. So AB is equal to AC. So that means that AB is equal to the same measure of AC. Now it's being dilated by using B as the center point. So that means that B to A is going to extend out. I'm going to put right there, I'm going to label this as A prime. It also means that AC is going to extend out, C prime. But then you still need to remember that the length from here to here needs to stay the same length as here to here. So these sides are still congruent to each other. From B to A prime is still going to be congruent to C prime to A prime. Okay. Now remember, the other thing that's very special about an isosceles triangle are that the base angles are congruent. Okay. And what I mean by base angles, I mean angle B is going to be congruent to angle C. And a dilation does not affect the angle measure. So whatever BC angle measurements are, that's also going to be C prime. But A has a different measurement. It's the vertex angle. So I'm going to leave that one at that. If you need any extra help, please see me after school.